Hi guys, welcome back to my YouTube channel. In this video, we are going to see about the working principle of a simple AC generator using a model. Let's start. Here is the simple model of an AC generator. You can go through my previous videos like a simple dynamo and electromagnetic induction to get basic knowledge about generator. Right. So you can assume this is a real AC generator parts. This is magnetic poles, that is north and south. There will be field between these two poles, and this part is known as a coil. You can assume this is a coil which can be rotated in between this magnetic field, and these two blue color caps you can assume as slip rings, and these two sponge you can assume as carbon brush, and this one end of the carbon brush is connected to one end of the bulb and another carbon brush is connected to another end of the bulb. So these are the main parts of this AC generator: coil, magnets, slip rings and carbon brushes. Right. By turning the handle, the coil rotates between the poles, that is north and south of the magnet. The pair of these slip rings rotates with the coil. You can see these slip rings are rotating along with the coil, and these carbon brushes are always in continuous contact with the slip rings when the axle is rotating. You can see these carbon brushes must always have in contact with these slip rings when the axle is rotating. Right. As the coil rotates, the upward as well as the downward motions of the arms cut the magnetic field lines, and an alternating EMF will be induced in this coil. The alternating induced current passes through the carbon brushes to the external circuit. So this is the simple working principle of a AC generator. These AC generators are also called as alternators because the induced current direction keeps on changing. So the direction of the induced current changes every half turn of the coil. The induced EMF has maximum output when the plane of the coil is parallel to the magnetic field. You can see at this point the induced EMF has the maximum output, or the induced current will be maximum when the coil or plane of the coil is parallel to this magnetic field, because the magnetic field can be cut by this both sides of the coil. So the induced current or EMF will be maximum when the coil is parallel to this magnetic field, but there is no induced EMF when the plane or coil is perpendicular to the magnetic field. You can see the north to south magnetic field lines can pass through this gap, so there won't be any magnetic field cut by this coil when it is perpendicular to the magnetic field. So repeating, when the coil is perpendicular to the magnetic field, there won't be any induced EMF produced in this coil. The induced EMF can be increased by increasing the number of turns on the coil, by increasing the area of the coil using a stronger magnet, and by rotating the coil faster. In these four ways, the induced EMF can be increased. I hope you are getting. You can see a graph here. This is the shape of an alternating current. Alternating current or AC means there will be change in direction. So graph will be like this. Let me explain in detail in terms of coil position. Now here the coil is now perpendicular to the magnetic field like this one. So there won't be any induced EMF. So when the coil is parallel like this, you can see this diagram B, the induced EMF will be maximum. Then again the coil is perpendicular, so no induced EMF, so it will be 0. Then again the coil direction changes, so again it comes parallel to the magnetic field like this. So the induced EMF will be maximum. Again it goes perpendicular like this, so EMF will be 0. So for one complete rotation of the coil, the graph will be in this way. So this is the graph of alternating current. I hope you got something. Let me conclude. When the coil is parallel to the magnetic field, the induced EMF will be maximum, and there won't be any induced EMF when the coil is perpendicular to the magnetic field. I hope you got it. Let's try a few questions from AC generator. Try this first question. Which device uses slip rings? Option A, a cathode ray tube. Option B, a DC motor. Option C, a solenoid. Option D, an AC generator. Your time starts now. The correct answer is D, an AC generator. Try this second question. Which diagram represents the voltage output of a simple AC generator? Your time starts now. The correct answer is B. Try this third question. The diagram shows an AC generator. As the coil passes through the position shown, the output voltage is plus 10 volt. When does the output voltage become minus 10 volt? Option A, when the coil has turned through 90 degree. Option B, when the coil has turned through 180 degree. Option C, when the coil has turned through 270 degree. Option D, when the coil has turned through 360 degree. Your time starts now. The correct answer is B, because in the question they have given that at this position the output voltage is plus 10 volt, that is 0 degree angle. When the coil keep rotating in this direction, it reaches to 90 degree at this position, and the voltage will be 0 because the coil is perpendicular to the magnetic field lines. Then again it passes through this position At this position, the angle will be 180 degree and the coil is parallel to the magnetic field lines. So it induces again 10 volt. Here it is minus 10 volt because there is a change in position of the coil. That is, the sides of the coil has changed when it comes to this position. So it will give us minus 10 volt. So let me conclude here 0 degree plus 10 volt, 90 degree 0 volt, 180 degree minus 10 volt. So the answer is B. Try this fourth question. An EMF is induced across a wire when it moves through the magnetic field between the poles of a magnet. Which electrical device operates because of this effect? Option A, a battery. Option B, a cathode ray tube. Option C, a generator. Option D, a motor. Your time starts now. The correct answer is C, a generator. Try this last question. In an AC generator, a coil is rotated in a magnetic field and an electromotive force is induced in the coil. In which position of the coil does the EMF have the largest value? Your time starts now. The correct answer is A, because the EMF have the largest value when the coil is parallel to the magnetic field. I hope you got something about the working principle of a simple AC generator. Thank you.